Welcome to .NET Testing Best Practices. I'm excited because here's the part where I tell you I am definitely going to post the slides on my site tonight. But in this talk, there are no slides, but the code is already online. Here it is, github.com/robrich/net testing best practices. And so you can get at the code that we're going to experience tonight. The cool part is we're just going to be typing. So we'll start from the start folder. Here's where we'll start from, and we will end at the done folder, at which point then you can get to here. And so you can clone this repository, you can do the same exercise that we're going to do, or you can just take a look at the answer as well. Thank you for the introduction. Here's where you can get this presentation and all the rest of the presentations, robrich.org, robrich.org. Click on presentations, and here's .NET Testing Best Practices. If you want to join me, I'm actually doing a talk tomorrow morning, scaling the testing pyramid in TypeScript, and that'll be really fun too. That one's in Kansas City, so come join us. So you can always go to robrich.org, click on presentations, and that'll get you straight to the GitHub repository. While we're here on robrich.org, thanks for the intro. Here's some of the things that I've done recently. AZ Give Camp is really fun. AZ Give Camp brings volunteer developers together with charities to build free software. We start building software Friday after work. Sunday afternoon, we deliver completed software to charities. Sleep is optional, provided. If you're in Phoenix, come join us for the next AZ Give Camp. Or if you'd like a Give Camp here in Salt Lake or Utah County or anywhere close, then hit me up on any of the socials and let's get a Give Camp in your neighborhood too. Pro microservices in .NET 6, that was a lot of fun to work on. I'm actually working on Pro microservices in .NET 10 right now. It should come out right as .NET 10 comes out in November. Some other things, well, let's actually dig into this code. Let's pull it up in Visual Studio and take a look at what we've got. So here's our code. We've got this light switcher that it would connect to IoT light. And we've got this motion sensor, it's going to sense light in the room or perhaps outside. We've got this light actuator, and this actuate lights method, that's our goal, is to test this method today. And so we've got this method. We'll take in if motion was detected by the by the motion detector, and it will update the last motion time. If it's light out, if it's dark out rather, and there was motion detected, let's turn the light on. And so maybe it's not a stateful light. We can turn it on even if it's already on. If it's light out or it's been longer than a minute, then we'll turn the light off. And then we have given a date time, go figure out what time of day it is. And so we then have a little bit of content here that just allows us to use it. So we have this motion sensor that's just going to flip back and forth every 100 milliseconds, on, off, just so that we have a motion sensor. And we have a light switcher that does nothing but write to the console. And then we have a motion sensor that will just flip it back and forth. And so we then have that rigged up. And so we just have enough of this IoT application to be able to do some interesting things. Any questions or thoughts on our application code or what we want to test, our goals here? Cool. Our first stop is to create a new test project. Here in the repository in the start folder, we don't have a test project. So let's come into Visual Studio and we will say add new project. Now there's a couple of different types of testing projects that I can use. If I switch project types to test, we have MS Test and NUnit and xUnit. We're going to use xUnit today because xUnit is the testing framework that ASP.NET uses to test ASP.NET. That's enough of an intro for me. I think that's completely fine. At the level that we'll play at today, it's pretty much the same. There are nuances and subtleties that will actually make xUnit a superior product in time, but if you're invested in NUnit or MS Test, then that is totally fine. So we'll click next and do all the things, and now we have this test project here. Now I have added a few NuGet packages that we would add throughout the process. xUnit is obviously here. We've got the xUnit runner. I've also installed shouldly and NSubsitute and autofixture. We'll use those throughout the day. And then we'll come to the end and we'll use our test logger too. Oh, it looks like I have some updates. That's cool. So we've got now our project set up. Let's create a new test. Add new item. I'm going to say hello world.cs. And so here is our test. File scope namespaces. I love that. Global usings. I love that. We have all of our usings here in this using.cs. So we don't need to specify them at the top of each program. Let's make this public and let's create a function. Public void run hello world test. Now to make it a test in xUnit, we give it an attribute of fact. In mstest and NUnit, we would give it an attribute of test. And so that's kind of the only difference between NUnit, mstest, and xUnit at this level. And so then we can do something. Let's say int expected equals 4, int actual equals 2, and then assert dot equal actual and expected. And now we can go run our test. So I'm going to come here into the test menu. I'll come to Test Explorer, and here's our Test Explorer, and I will run all tests, and it will go discover all of the test methods in my project, those that have this fact attribute, and it will run them. And in this case, we see we got a failing test. Well, of course, 4 doesn't equal 2. Let's make 4 and 4. And we will rerun our test. And now we see it passes. So we're green. Excellent. Well, let's go back to the 4 and 2 example. Here in 4 and 2, I was debugging my test, and I spent a really long time debugging it because, well, it said it expected 4, and when I debugged it, I got 4, but it was failing the test because it says I expected 4, but I got 2. Well, actually, that's because I had gotten actual and expected backwards. Or maybe actually I did it right the first time. Maybe it was supposed to be that way. I don't remember. There's 2 parameters and they're confusing. So let's not use assert.stuff. Instead, let's use shouldly. Now in the past, we've used fluent assertions. It is no longer free. And so let's use shouldly that has a pretty much similar syntax. So yeah, we could assert.that, but instead, let's do it this way. Something dot should be something else. So we can say actual dot should be expected. And if we wanted to, we could give it a reason, some kind of custom message where we could say expected but got actual, and that's interesting, but that's actually built in. So in this case, we don't need that message, but we could provide extra data. Maybe we're validating a status code on a request or a response, and we want to show the response body in our assertion. Cool. Now the cool part is this is implemented as an extension method, and because it's an extension method, even if we had something like this, it will still work. We don't get a null reference exception because we have this method somewhere. It's called like this, public static void should be object value. And well, maybe it's nullable, but it's actually, it should be of t. So this is a t. And so then it still gets called even if this is null. This extension method means that we will not get a null reference exception even if this value is null. That's cool. That's wonderful that we don't have to worry about this. And now actual dot should be expected. We can just kind of read that. That makes sense. Is actual and expected backwards? Not anymore. So let's make this be 4, and we will run this test again, and we get it to be green. Excellent. Any questions about our Hello World test? Any questions about shouldly?
Could you recap real quick? The fact just means it has no parameters and it runs every time, or does it mean something else?
Fact just means that this method is a test.
Okay, thanks.
Yeah, great question. So let's create a new thing. We want to test this light actuator actuate lights method. So I'm going to create a new item, and I'm going to call this light actuator underscore actuate lights tests. Now this public class will be all of the tests for this class for this method. Perfect. And so by naming this class this way, as we have a failing test, we know exactly the thing that we were trying to test. We'll actually see how we get stack traces as well. But here's a best practice. Name it class underscore method underscore tests, and that makes it really discoverable. So let's take a look at our code and see what things we want to test. Well, public void motion detected should turn on light. That sounds like a good method. GitHub Copilot is cheating. And we will put a fact attribute on it. Now, if we were to run this test right now, it would pass because there are no assertions that cause it to fail. So I'm going to add this, throw new not implemented exception. And now if we run the test, they will correctly fail. I like to add this piece into every test before I implement it so that I don't accidentally create passing tests by not implementing the test. That would be really unfortunate. So there's our first one. Motion detected should turn on light. Next, let's do the opposite of that. Well, what if motion detected is false? Actually, no, it shouldn't turn on light. Motion detected, update last motion time, because we're going to go check this. And now let's do another one. Let's say motion not detected, last motion time not changed. Cool. Next up, let's say this one. Well, we can say dark, motion detected and dark, turn on light. And we could say motion detected, well, we want to test evening, we want to test night, we want to test morning, we want to test afternoon. These tests are going to be really similar. And so, yes, we could do that with this one as well, but let's see if we can do this a little bit differently. I want to say inline data. I want to say in the evening, yes, you should turn on the light. And at night, you should turn on the light. And in the morning, you should not turn on the light. And in the afternoon, you should not turn on the light. Now to do this in xUnit, I changed fact to theory, and now I can pass in these parameters: string, time period, and expected turn on. Cool. Now I've just built 4 tests into this one test method. Oh, cool. There we go. I've now built all 4 of these tests into one test method. They're all going to be implemented pretty much the same. So let's just have them be one test that takes parameters. And that can be a really, really good way to keep our tests dry-er. Now, there is an argument to making our tests super dry, but that makes our code super complex. Let's not focus exclusively on making our tests dry, but instead focus on making our tests really legible. If our tests are a little bit redundant, that's okay. Our goal is to make our test code simpler than our production code. And if our test code is simpler than our production code, then we're less likely to have bugs in our tests and you be able to use our tests to validate our system. So yeah, we're going to use this to keep our tests a little bit dry, but we're not going to worry about trying to overly abstract it. Should we now do the turn off test in the same way and add a third one? Bool turn off. And no, that would make it too dry. It would make our test too complex. No, that's not a good move. So we've got all of these together, and yeah, we could do the same thing here, passing in true and false, but no, let's keep those separate and we'll make them simpler. Similarly, let's test to see here. We want to say motion not long enough and light, turn off light. And we want to say this is expected turn off. Now, in the afternoon, it is light. In the morning, it is light. In the night, it is not light. And in the evening, it is not light. And so now we've got tests. Now, the other thing that we'll want to test, and if we have time to do it, that would be great, is test if it's been long enough and turn off light. Cool.
Hey, Rob, we've got a hand up by Jim R.
Ooh, Jim R, yes.
Jim, if you want to come off mute and go ahead and ask your question.
Yeah, so I noticed in the code right there on line 58, it says time period evening, time period night. I noticed on line 63, it has time period morning, time period noon, but your test doesn't do anything with noon, but instead does something with afternoon.
Yes, it is. And we'll come back to that one because this method actually returns afternoon. We'll use our test to find that bug. Good find. Any other scenarios that we need to test in this code other than the ones that we found today? Well, cool. Let's start implementing them. So the first thing we want to do is this test. I'm just going to copy this code into place just so that we can not have to flip through it quite as much. That's the code that we want to test here. Let's introduce the arrange act assert pattern. This is the setup, this is the doing it, and this is the validation step. So you might have setup, do, and validate, or I kind of like arrange act assert because they all start with A and they alliterate, and that's kind of fun. So let's kind of TDD our test. Now I want to say this is a light actuator, and then light actuator.actuate lights. True doesn't mean anything here. So let's say motion detected. That's going to be a whole lot more descriptive. Now that's what we want to do in our test. We also want to check the last motion time. So let's say date time last motion time equals, let's go get the last motion time. And we can even say this is actual last motion time. And so now we want to say actual last motion time dot should not be default last motion time. Okay, so if we have a default last motion time, then we need to say light actuator dot last motion time equals default last motion time. And now we've got that set. We can also say should not be, well, we can even say dot should be greater, so that, you know, we know that this one is later than, we could actually even test that it's kind of close to now, because that's what our code does. It sets it to now, but let's not. But should be greater is a good thing. So now that we've created the code that will flex our thing, and we validated what we want to assert, let's see what we want to arrange. Well, we need a last motion detected is true, so you know that there's that. We need a default motion time, and it can be new date time. I don't know, 2001. We just need something, and let's document this. Something before now. And so it doesn't matter how long before now, the value of 2000 is not important. It's just we need something that is not now. Cool. So we can now remove our not implemented exception, and we're ready to go. Kind of. We're going to get a compile time fail because we can't set last motion time. Flipping back to our application code, we can see that last motion time is private. Now we do have an interface, so anything that deals with it won't get at it, but I'm going to make this public so that we can test it. And I will add a comment, public to be testable, not part of interface. Because otherwise, the next developer that comes behind me is going to want to go make it part of the interface, and no, it needs to be not part of the interface. The other option that we could do is we could make it protected and then implement derived from light actuator to make it public for the purpose of the test, or we could make it protected and make this assembly of friends visible to the other assembly. Both of those are decent solutions, but require more stuff. This is just really easy. I make the actual implementation public, and I make sure that it is not part of the interface. You could even go a step further and say, date time, last motion time is not part of the interface, used only for testing, or public only for testing. You know, putting that comment there might be a good way just to make sure that the next developer doesn't automatically add it to the interface. Cool. Now that it's public, we can come back to our test, and our test will compile, and let's run our test. Last time we ran it here, we ran all of the tests. Instead, we could pop open this one and say motion detected, update last motion time. Let's just run that one test. And that one test is green. No, that one test is red. Let's take a look at it. I'm going to say open test log, and now we don't have to scroll around this tiny little window. And ooh, it says, here's our stack trace. We went to go get the instance on line 20, and it says light switcher is not initialized. Let's go there. On line 20, we have this singleton pattern to try and get this light switcher. Well, we're using the light switcher down here to turn on the light, which is definitely a thing we want to do, but is completely irrelevant to this test. Okay, our goal was not to modify our production code, but in this case, we need to modify this to be able to get rid of this, you know, singleton thing. Well, should we initialize it at the beginning of every test? Because we can't re-initialize it, then, well, how would we clear it when we want to pass in a mock instead of the actual one? Yeah, let's not. Let's just get rid of this whole singleton thing. And to that end, let's just yank this interface out of this static class, and we'll just have that interface up at the top. Cool. Now, in our code here, thank you to default constructors, we can take an light switcher, light switcher, and now that light switcher, instead of using the singleton, we can use our instance that is passed in. And now we have a light switcher that we can take much more control over. Excellent. Well, in our production code, we now have a thing. There is no light switcher in it. So rather, let's say var light switcher equals new light switcher, and we'll pass that into our light actuator, or we'll pass the light switcher into the light actuator. Oh, our light switcher instance also derives from lightswitcher.iLightSwitcher. Embedding that interface inside the class was probably not a good idea. There we go. Now our production code is ready to go. We can build our library, build, and now back at our tests. Oh, we need to pass a light actuator in here. Now, the cool part is the light actuator is just an interface. We just need something that implements this. So we could come here and we could say public class fake light switcher derives from iLightSwitcher. Thank you, GitHub Copilot. Maybe we're implementing it, maybe we're not. We can like keep track of it, or we could just have these methods do nothing. But writing that class is kind of annoying. Could we just, I don't know, automatically gin this thing up? Let's delete this class and take a look at a mocking library. Now, previously, we might use MOQ. In this case, we're going to use NSubsitute because MOQ includes spyware. And so we can just say substitute for and pass in an interface, and it will give us that thing. So let's do that. Let's come in here, and we want to say, I'm going to create a new mock section. And I'm going to say, I would like an mock iLight switcher, please. Let me get a substitute.for iLight switcher. Did I not spell substitute right? Substitute for, and then we can pass in our mock light switcher, or I can even just call it light switcher in this case. It's obviously a mock. And now we've got that we've correctly solved for that dependency. Okay, now with that in place, we solved for that dependency and we didn't need to build any new class. Now let's run the test. Previously, we came in here and we just said, I want to run just this test, but let's actually click on the method inside Visual Studio and just say run test. And it will go build it if it needs to. In this case, it did. And then it will run just that one test. And if we pop open the Test Explorer, we can see that that is green. Now this one's green, but this one's kind of dulled out now. Did our code change in a way that would make that test fail? We don't know yet. And Visual Studio doesn't either. And so it just said, I don't know. So I'm just going to say it passed last time. Cool. Okay, so we just said if motion detected, we update last motion time. In here, if motion detected, we updated last motion time. We validated this if block worked. Let's validate the alternate position of that. And so we'll just start by copying all of this and pasting it in here and say, in this case, motion detected should be false. And so in this case, it should be equal to, or even just should be. Well, what if maybe if I serialized it and deserialized it, date times kind of have a little bit of a difference. And so I'm going to say within this tolerance, I would like to say, I want it to say time span dot from seconds. I don't know, I'll give it a 3-second boundary to it, or in this case, probably 1 second is enough. So if it's up to 1 second after or up to 1 second before because of rounding errors of serializing it back and forth between a database or serializing it back and forth between a JSON file, that'll be okay. Cool. Let's run this test and see if that works. Now we can see that the majority of the test was the same. Should we take that additional step and make it dry by passing in parameters? Well, in this case, probably, maybe, but I don't know. Let's see. In this case, we'll just leave it separate so that we don't have to worry about a understanding a non-parameterized test. Next up, motion detected and dark, turn on light. Okay, so let's start with this one, and we will build this up. So in this case, we have a default last motion time, and in this case, motion was detected, and it's dark, so we need to set our time period, and then we can say, bool actual turn on equals false, and then we can say actual turn on dot should be expected turn on. We're closer, but we're not quite there. We need a way to set our actual turn on, and we need to use our time period. Well, how should we know that we turn on? Well, actually, let's set time period first. Now we call this get time period method, and we get back a time period passing in some date that, I don't know, I don't care what the date is. Could we set the date to a particular time such that, how about we just take control over what this method returns? Okay, so I don't know, let's do something like light actuator dot time period equals time period. Well, that's a little weird. There's no property there. We're just kind of getting the results of this method. But unfortunately, this method is private. Let's separate this method into a separate class so that we can pass it in as a dependency so that we can fake it. Public class, I don't know, time period helper, which is probably a really nasty name, but okay. This is now public, and let's create an interface. Now, if I was doing this in another way, I might choose to move this to a completely different file, but in this case, I'll just put it right here because, our application code is all in one file. Oops. So now I have an time period helper that can do this. And so let's take in an time period helper, and now we'll use our time period helper dot get time period to do it. Okay, cool. Now we just split this private class or this private method into a separate class. So we don't need to update a whole lot with our production code, but we do need to be able to pass in this dependency. So let's go back to our production code here, and we need a new dependency. We need a time period helper. Var time period helper. I'm tired of having to modify stuff just because I'm adding new dependencies. I bet we're not done. Well, in ASP.NET or in service projects, or we have a mechanism where we can just kind of do dependency injection. Let's take a look at how we might be able to do dependency injection in a console app. So let's come over here, and there's a great article from Andrew Locke about how to do dependency injection in a console app. Yeah, if we did this as any other kind of app, we could just kind of do magical things. But first step is depend on the Microsoft extensions dependency injection. I've already added that to my project. And so next up, we want to create a service provider. And then we'll use our service provider dot build. And then we can just say service provider get service and do the interesting things. So let's do that. Let's come in here and go grab our service provider. And actually, let's go like this. Var IOC, or we can even say builder equals, nope, var IOC equals new service provider. And then we'll add a bunch of services to our service provider. Let's go like this. Now, in this case, we'll add them as singletons. Oh, I did call it services. We'll add them as singletons, but we could add them as anything. New, service collection. There we go. We could make them anything we wanted. In this console app, singleton is completely fine. Getting the same instance back is great. And then when it comes time to, when it comes time to create a new light controller, we can just say services dot get required service of type light controller. And we don't need to worry about dependencies anymore. Oh, wait, I need to build it. Var IOC equals services.build service provider. And then this is IOC.get required service. Cool. Now we don't need to worry about our application. If we have more dependencies, we just need to register another provider, and it will just automatically work itself out. Excellent. Now our production code builds, and we could run our app and see that it functions correctly. So back in our test project, let's build this. And okay, I need to go create another mock. I need to pass in. Is there a way that we can use dependency injection in our tests? Before we go there, any questions, any thoughts on how we use dependency injection here in our console app? Cool. So we want to use dependency injection now in our tests too. And that's where AutoFixture comes in. Now, AutoFixture allows us to be able to create this IOC container and then add the dependencies that the mocks that we care about. And then when we go create a thing, if a mock doesn't exist yet, AutoFixture will just invent one for us. It will build a default mock for us. So in this case, I'm going to say var IOC equals new fixture dot customize new auto and substitute customization. I now have that IOC container. I don't need this light switcher. I'm not doing anything with it in this case. And now I can say, hey, IOC.create this light actuator, and it's going to go build the light actuator, putting in whatever dependencies it needs. Now we need to pass in the NSubsitute rules here because AutoFixture is not tied to a particular mocking library. We could plug in lots of different mocking libraries. In this case, we're using NSubsitute, and that's why we need to configure AutoMocker with this NSubsitute customization. Cool. So let's do that here, and let's do that here. And now let's also do that here. And now we don't have to worry about the things that are done in interesting ways. We don't care about the time period in this case. Oh, that's not how we do it. And then we'll say bool actual turn on equals false. Cool. We wanted to do that so we could take control of this time period. So let's say var time period helper equals IOC.freeze. I don't like this freeze. I would rather a mechanism that was like IOC.mock. It's IOC.freeze. We want some time period helper. And so then we can say time period helper dot get time period. I can pass in any date that I want, and it will return this time period. Cool. Now, I also want to take control over knowing when I turn this on. Well, I just need to pass in some iLightSwitcher. So let's come back here and create a second mock. I want to say var lightSwitcher equals go make me a light switcher. And now I want to say lightSwitcher dot when turn on is called, then do, hey, set this flag. Now I could go down here and I could say lightSwitcher dot verify and do interesting things there, but I actually find it a little bit more descriptive to just kind of create this bool, and when that method gets called, set my bool, and so now I can kind of get a good feel of what's happening here. Now let's create, let's put in a breakpoint right here, and we will step through this test. I'm going to, instead of calling run tests, let's call debug tests, and now we'll get to see how this mock process works. Cool. So we've set up all of our things. We've passed in the default motion time. The actual last motion time is probably irrelevant. Let's remove that. We'll get it to rebuild. And then let's get into actuate lights. F11, F10. Was motion detected? Yes, it was. So we set our last motion time. Now let's go into our time period helper. Well, that time period helper right here is this time period helper. And so we passed in this time period, which happened to be morning in this case. And so we see that this time period is morning. Perfect. So if we have motion detected and it's dark, then we should turn on. But in this case, we didn't. And so we'll turn off, which we didn't listen for. That's totally fine. Let's continue again. And now in this case, we've got night. Ooh, night's when we'll turn this on. Let's go check out that one. F11, F10, lots more F10s. It's night? Excellent. So is there motion detected? Yes, there is. Is it night? Yes, it is. So now let's call the turn on method, F11, to step into this. And we see that we're now in the middle of our mock setting this value to true. So F10, we're back in our actual code and we'll finish this method. So now that actual turn on is set to true. So actual turn on dot should be expected turn on, which is true, and our test passes. So let's, oh, not that. Let's now go run all of those tests. Motion detected and turn on, run them all, and we can see all 4 of those tests are now green. Excellent. So in this case, we needed to create some mocks, one to be able to set the results of a method, one to capture when a method is called, and we were able to do both of those to prove that we can turn the light on when it's dark. Any thoughts or questions or concerns here?
So if any one of those fails, then the whole test fails? Or are
Yes.
they separate tests?
There are actually 4 separate tests. If we open this, here's that method, and here's the 4 separate tests that run. So if one of them failed, let's say we wanted afternoon to also turn on the light, and then we reran this test, then we would see that 3 of them would be green and 1 of them would be red. Or in this case, it didn't even run.
Yeah, and to state that another way, because the test has the attribute of theory and it's a parameterized test that you're passing in the inline data, each of those inline data elements is treated as a separate test. So it's possible that only one of those tests fail instead of all 4 of them failing because one of the inline data had returned the incorrect value.
Right. Theory then says that I'm a group of tests instead of an individual test. Then each of these makes a separate test that can pass or fail in isolation.
Okay.
So let's do the same thing when we turn off the light. Now, in this case, we want to say, we want to call turn off. And is motion detected? Well, if motion was detected, we would fall into this one. So what we're worried about here is not so much motion detected as much as the last motion time hasn't been long enough. So we're going to say this one is date time dot now dot add time span dot from seconds -3. Something before now, but not long enough. If it's been long enough, then we will choose to turn off the light anyway. We want to make sure that we're validating this portion of the code there. So now that we have our default last motion time that's within bounds, expected turn off here, this is an actual turn off. This is a turn off. This is a turn off. This is a turn off. And this is a turn off. Well, basically, we just rename things. Should we, I don't know, create some kind of combined thing where these two tests kind of merge together? Well, we could, but then we'd end up with if blocks in our thing, and we'd end up with a bunch of different mechanisms. We're trying to do that code would become more complex, and it would be more likely that we would create errors in our tests rather than just validating our code. So in this case, we are choosing not to be dry and instead to be simple.
So this not long enough is bugging me.
What's bugging you about not long enough?
Because we have a hard-coded value in our main code, but
Right.
we don't know what that value is. And
yes, we are
who's
assuming
to say,
that.
I guess what I'm trying to say is, who's to say that some do-good programmer is going to say, oh, well, you know, we want that time frame to be 2 seconds rather than 100 seconds. And now our
Yeah.
test will fail.
Good call. We could choose to change our application code to make this a parameter. You know, maybe it's a constant here, or maybe it's, and then use that constant in our test to maybe set this to half of that. And we could definitely do that if we chose to. In this case, we're trying to modify our production code as less as possible. And so I think it's a decent assumption, but we could also add this. Fragile, assume less than time out period, you know, something like that. And that better documents that we've made that assumption that this is less than the value that we're looking for.
So if you're trying not to modify the production code, I think you've passed that bridge a long time ago.
Yes, I did separate out this time period method. I did pass in a light switcher instance, but that was necessary to make the code function for testability, but it was the lightest touch that we could make against this code. The cool part, though, is that other than the time period helper, we'll see how that the time period helper, splitting that apart, didn't change how people call actuate lights or how the light switcher or the motion detection works. It just is kind of the interface between this method and that time period method. And so even though we split it out into a separate thing, we didn't impact the rest of the system in any way. And that was really helpful too. So let's run this test and see if this passes. And we'll see there's our build. And we got 3 passing and 1 failing. Uh-oh. Well, let's take a look at this one, and we'll put a breakpoint right there. And we'll say, I would like to debug this one, please. And so now we're looking at the time period of afternoon. F10, F11, F10s. Yes, motion detected, so we updated last motion time. Our time period is afternoon. Is it evening or night? Nope. Has it been long enough? Nope. Is the time period morning or is the time period noon? Oh, we've got a failure here. The 4 values that we have are night, morning, afternoon, and evening. And here we said night, morning, afternoon, but not afternoon. We said noon. We were using our test to validate our system, but in this case, we used our test to discover bugs within our system. That's cool. Now, it would be trivial for us to just change this to afternoon, and now we've solved the problem and our tests will pass. But what is the problem here? The problem here isn't so much that we did a typo in this name. The problem is we can't discover this until runtime. We don't have a compile time mechanism to validate this.
Can we have a using that would then make this a little more clear?
Let's do that. Let's do this. These are magic strings. Let's instead create an enumeration. Public enum time period. And GitHub Copilot has seen me do this before, so it knows where I'm going. Night, morning, afternoon, evening. Now that we've got an enum, we don't have our magic strings. Let's say this is time period.evening, time period.afternoon, time period.morning, time period.night, and we will return a time period instead of a string. Now we do need to return a time period here, but because this class is only used by this class, the only other place we need to modify this is right here. We're returning the time period. Let's also match this to the time period here. The time period here. We'll now go change this one as well. Time period dot morning, time period dot noon. And now we have a compile time failure about this typo rather than a runtime failure. That's better. I'm glad that we built this test to be able to validate this portion of our method so that we could find that that was a typo. Cool. Now our production code will build correctly. We didn't need to change anything over here. Those didn't really care about the interface between time period helper and light actuator. So that worked out well. We do need to modify a few things here in our tests because we passed in magic strings up here too. So let's make those time periods. And time period dot afternoon, we'll take out the quotes here too. And we'll make this a time period going in. We will also do that here. And it's about this point where GitHub Copilot notices that that's what I'm doing and says, hey, can I help you fix it? I just ignored it and kept plowing on, but there we go. Now our tests will build and we can run all of our tests together and we see that they all go green. Excellent. We used our test to be able to validate our system functionality, but we also used our test to discover system functionality, and to that end, to discover bugs in our system, and then to be able to resolve them. I'm really glad that we had these tests that helped us identify this bug in our code, and taking a step back, we were able to fix the problem, not just the symptom, by switching from magic strings to an enumeration. Any questions or concerns or thoughts right there? Gary's got a question. I'm excited. Nope, never mind. So our last test.
Oh, Jim's got his hand raised though.
So what happens when your employer says, we don't use those libraries that you just did because they're not secure or we haven't vetted them? All of a sudden, all of this that we just did isn't going to be useful because the all of these magic plugins that you created or that you added aren't available to us?
We used NSubsitute, we used shouldly, we used autofixture.auto NSubsitute, those 3 libraries. And well, all 3 of those libraries are open source, and none of those libraries will get deployed with our production code. And so if your employer is really grumpy about things that we use to build our code faster, we could definitely create them, or we could go to the source code for each of them and shouldly. We could go to shouldly and we could go grab the apparently I'm not getting to shouldly.com. We could go to the source code for shouldly and go clone it and put it in our repository. And now we're not using an external library, we're using an internal library of that code, or we could write something similar. If we can't use libraries, yeah, that might be hard. But I would argue that because we're not deploying these libraries, it's probably okay. Now, that is an assumption, and your employer may differ with my assumption, but I think it's probably okay. Cool. So now we want to test if it's been long enough. I'm going to leave that to the reader to implement that, but we do have an answer for that here in our repository in the done folder. So you can look to my answer, or you can think through how you might build your answer. And that could be really, really fun. Next, let's talk about doing this in a DevOps pipeline. Now, we could come in here. Here's our code, and we could say .NET restore, and then .NET build. We'll build in release mode, and then we can say .NET test, and that will run all of our tests, and it will give us this cool thing. In this case, we've got 11 succeeding, and that is awesome. Now, we do want to kind of enumerate all of our tests and output that to a dashboard. Now, to do that, let's reach for this. Not there. This. Nope, not there. Here. Let's use JUnit test logger. Now, JUnit is a log output format, a test output format, originally created for Java, but it's not specific to Java. And so if we output in JUnit format, then most dashboards will just be able to slurp that in and use it. So, okay, let's come in here and we'll add one more NuGet dependency, and we will look for JUnit logger, JUnit XML test logger. And with that in place, we can now come in here and say .NET test, and we'll give it our logger JUnit. We'll also give it a log file path. We can also turn on code coverage and send our code coverage to an interesting place. And so with that command, now we'll get a new folder here that is all of our test results. We can publish that test results folder to our DevOps dashboard, and now we can see the details of all of our tests. Now, the interesting thing about that file is it's, really difficult to read, but it shows the results of each test and how long it took to run that test. We also have our code coverage details here, and so we could visualize that in our dashboard as well. So let's build a DevOps pipeline here. Well, we talked about the commands that we would want to run. We want to run .NET restore, .NET build, .NET test, and then we'd want to run .NET publish. So let's come here into our DevOps pipeline, and we will take a look at how we'll build it. Now, in this case, I'm building my DevOps pipeline inside GitHub Actions, but we could just as easily do it in Jenkins or TeamCity or Visual Studio or Azure DevOps. But that's what we're doing: .NET restore, .NET build, .NET test, passing in that logger statement to put our results in the correct spot. And then let's also use this test reporter. Now, this test reporter allows us to be able to publish the test results in interesting ways. It knows how to read JUnit results. It also knows how to read xUnit, NUnit, and MS test results if we chose to put our output in that one. And so we'll come here into our DevOps pipeline and publish those results into our DevOps pipeline dashboard. Now I will call out right here, we're doing this always. If our tests fail and we didn't have this run always, we would not publish our results if we got a failing test. That would be bad because we really do want to publish our tests all the time, even if they failed. So we're going to run this step always, not just if previous steps succeeded. So if we choose to run this build, and I'm not going to kick it off right now, but this is the one that ran yesterday. 5 days ago. Then we have our build pipeline, and it does all the steps. Here's that build pipeline that will run it, and we've got 18 past tests. We can also take a look at our test results, and now we see those 18 past tests in 234 milliseconds, and we see each one and how long it took, together with all the details, and we can now visualize all of these test results in our DevOps pipeline. Any thoughts or concerns? Any questions on DevOps pipelines? So the cool part is we have a start folder that is where we began without a test project. We have a done folder that includes the test project together with all of that actuate lights test, together with a getting started test, a hello world test. And so you can now do the same experience that we did, and you can grab this code on github.com/robrich/net testing best practices. It was really fun getting to share with you the .NET testing best practices today. Thanks for coming.